All right, so continuing on with day 2, talking about the binomial model. We just talked about the formula. This is the formula for calculating binomial probabilities here. The way you do n choose x right here, I'm going to show you how to do n choose x here. So let's say, looking at this previous example that we did, n was 3, and if we look at this probability back here, x was 2. So if we just calculate this probability using the formula, I want to show you how it is very similar. Okay, so the formula, the probability, if I'm going to use the formula to find the probability that x equals 2 shoppers said yes, that would be 3 choose 2 from this first part. Okay, p, the probability of success, was 0.7. We're going to square that because x is 2 to the x power. And then q, which is 1 minus p, the probability of failure, 0.3, to the n minus x. 3 is n, 2 is x, 3 minus 2 is 1. So if I just do this calculation on my calculator, okay, so the way you do 3 choose 2 on your calculator, if I want to do 3 choose 2, 3 choose 2, okay, I'm going to go hit the number 3, and then I'm going to go to math. Okay, so I'm going to hit 3, math, go over to PRB, so over to PRB, and then notice number 3, NCR. So, and then hit enter, 3 NCR, and then hit enter. And then it should show up here, and now you have to hit the 2 and then enter again. So these are the steps. So this will be, you hit your x first, or sorry, you hit your n first, whatever your n is, the number of trials, math over PRB, then you hit your x, and then you hit the NCR, enter, and then you hit your, or sorry, not, that's still number 3. So PRB 3, and then NCR, then enter, and then this is your x. And then enter again, 2, enter, and it gives you 3. So this was 3, so I'm going to take 3 times 0.7 squared times 0.3 to the first. Remember, this is the number of ways that 2 people said yes. The number of ways. N choose x, 3 choose 2 is the number of ways 3 people said yes. So I'm going to take 3 times 0.7 raised to the second power times 0.3 raised to the first power, or just 0.3, and that gives me 0.441, which is the same probability we found on the previous page. So that's how you use the formula. You don't really need to know how to do this. You can do this using factorials. So if you want to know another way to calculate n choose x, if you don't want to use the NCR button, is to say, well, n is 3, so that would be 3 factorial divided by x factorial, which is 2 factorial, n minus x is 1 factorial. Well, 1 factorial is just 1. So really I'm taking 3 factorial divided by 2 factorial. And the factorial simply means, okay, it means take 3 times 2 times 1. So on the top you'll be taking 3 times 2 times 1. On the bottom 2 times 1. The 2's and the 1's cancel, and you get 3, just like you did on the calculator when you did n choose x up here. So this is just another formula you can use to calculate the n choose x part of the binomial probability formula. Okay, so now we're going to look at an example. Suppose that you rolled a die 4 times, and you're going to let x equal the number of 6's. So all we care about is the number of 6's. Find the probability model of x and the probability that you get 2 or more 6's. All right, so x is a binomial distribution. We need to come up with n and p. So n, the number of trials, we're going to roll it 4 times, so n is 4. And the probability of success, the probability of getting a 6, is 1/6. So x is the number of 6's, the number of 6's that we roll out of 4 rolls. And x is approximately binomial distribution. N is 4 and p is 1/6. So that's the definition. So how many 6's could I get if I roll a die 4 times? Well, I could get 0 6's, 1 6, 2 6's, 3 6's, or 4 6's. The probability of each of those is going to be calculated using a binomial distribution here, our binomial formula. So what I'm going to do now is I'm going to calculate x equals 0. So the probability that x equals 0, I'm going to use my binomial formula from above here. I'm going to use n choose x. I'm going to use p to the x power and 1 minus p to the n minus x power. That is how I'm going to calculate the probability that x equals x. I am simply using this formula each time. The x is going to change from 0 to 1 to 2 to 3 to 4. So that's all I'm going to do. So n is always 4, so the probability that x is 0 is 4 choose 0. And the probability of success is 1/6 to the 0 power. And 1 minus 1/6 is 5/6, so the probability of failure is always 5/6. And n minus x for minus 0 is 4. Basically, these two powers have to add up to n every single time. These two powers, the probability, the success and failures have to add, the number of successes, the number of failures have to add up to the number of trials. That should make sense. If you're going to roll a die 4 times, you're going to get so many 6s and so many not 6s. Okay, so we calculate this. If you do this on your calculator, you end up with okay, so that first one was 0.4823, so that just goes up here, 0.4823. And then the probability that x equals 1 is going to be 4 choose 1. Okay, this time x is 1, so the x's, all the x's in the formula are just going to get replaced with 1. N is still 4, and this is still 1/6 and 5/6. So 4 choose 1. If I do that on my calculator, 4, math, PRB, 3, and then hit 1, that gives me 4, so that number, that would have been 4. 4 choose 0 was actually just the number 1. So then I'm going to take 1/6 to the first power and 5/6 to the third power. I had 1 success, so the probability of success is taken to that power, and there are 4 trials, so the other 3 were failures. If you multiply those, you get 0.1157, so 0.1157. Probability that x equals 2 is going to be 4 choose 2. If you do that on your calculator, well, I just do the whole thing on my calculator. 1/6 is now to the second power because x is 2, and 5/6 is to the second power. And if you do that one, oh whoops, sorry, I had the wrong one for 1. 1 should have been 0.3858, 0.3858, and 2 is the one that's 0.1157. So switch those around. Okay, now the probability that x equals 3, all of the x's just changed to 3's now. So this will be 4 choose 3, and 1/6 to the third, and 5/6 to the first. And that one, if you do it on your calculator, four choose 3 is 4 times 1/6 raised to the third power times 5/6 raised to the first power is 0.0154. 0.0154. Now, we could calculate the fourth one, and I will, so I'll write the formula. Probability that x is 4 is 4 choose 4. There's only one way to choose all 4 6's, and that would be 1/6 to the fourth power and 5/6 to the 0 power. So 4 choose 4 is 1. 1 divided by 6 raised to the fourth power is really small. So like 0.0001 pretty much. I mean, if you take 0.4823 plus 0.3858 plus 0.1157, I'm just adding these up, plus 0.0154, you get 0.9992, so take 1 minus 0.9992, and this is 0.0008 is actually what that one ends up being based on our rounding. All right, so all of these we just used the binomial formula. All right, so the mean and standard deviation of a binomial random variable. Well, if it's, you've got a binomially distributed random variable with n trials, probability of success, so x is binomial n comma p. The expected value or the mean is just n times p. And the standard deviation is the square root of n times p times q, or the square root of n times p times 1 minus p. Okay, so we just want to find means and standard deviations probably. So actually we're asked to use a binomial distribution here. So we have a little different scenario. Suppose that 75% of customers at a gas station choose 87 octane gas. Well, that's P. Probability of success is 0.75, so 1 minus P is 0.25. And you're going to go observe the next 50 customers, so N is 50. So this means X is binomial with N is 50 and P is 0.75. So there's our distribution. It's a binomial distribution. And we want to know what is the probability that X equals 40 out of 50 by the gas. So that would be 50 choose 40. And that would be the probability of success, so 0.75 to the 40th power. And then 1 minus P, the probability of failure is 0.25 to the 10th power. Because 50 people, these two have to add up to 50. So when you do this calculation, you get So 50 math, PRB, 3, 40, and I'm going to take that times 0.75 raised to the 40th power times 0.25 raised to the 10th power, and I get 0.0985 is my probability. Okay. So what is the probability that the proportion of customers who choose 87 octane gas is 0.7? Well, 70% of 50 people, okay, we're still observing the same number of people, is 35. So our X is 35. So this is the probability that X is 35. So the only thing that changes here is the 40 changes to 35, and the 10 will then change to 15, so they add up to 50. So this is 50 choose 35, and then 0.75 to the 35th power, and 0.25 to the 10th power. And if you do that calculation on your calculator, you get 0.0888. Pause it and see for yourself. Okay, how many customers do you expect to choose this? This is just the expected value, or the mean, which is just n times p, or 50 times 0.75, which is 37.5 people. We would expect, on average, 37.5 people to choose that kind of gas. The standard deviation is the square root of n times p times 1 minus p. So that would be the square root of 50 times 0.75 times 0.25, which is 3.062. So approximately a range of 3 people from here we would expect to 68% to be. So it says, what is the probability that the number of customers who choose 87 octane gas will be within 1 standard deviation of the mean? So the probability that X is between 37.5, minus 3, 34.5, so about 35, and add 3, 40.5, and 41. So the probability that X is between 35 and 41, you can't have a half a person here, so we're just going to round. So we just basically want to calculate what is the probability that X is less than or equal to 41 people, and the probability that X is greater than or equal to 35 people. And this is where I'm going to get the calculator out. This is also in your book, how to use this. We're going to use something called the binomial CDF, okay, which if you go to your distribution, let's see, second distribution, binomial is down a little ways. Binomial CDF is 8. So second distribution 8 to get to the binomial CDF. And then you're going to type in N, P, and we'll have to finish this on the next video, which will be pretty short.